this video, we'll show you the steps to find the density of 3 different objects, and all of them are of different shapes. The first object is the eraser. As you all know, the density is found by dividing the mass by its volume. So to find the volume of a regularly shaped object like the eraser, you would need to measure the height, length, and breadth of the object. For this, we have decided to use the micrometer screw gauge, as it is much more precise than an instrument like the vernier caliper. We took the measurements of the length, breadth, and height of the eraser at 3 different points each to ensure that it is uniform. The results are shown in the table below. This slide shows the details and the steps to find the density. We use the electronic balance to find the mass of the object. We find the volume by finding the product of the average length, height, and breadth. The mass was found to be 9.1 grams. Therefore, by dividing the mass by the volume, the density of the eraser is found to be 1.00 grams per cm cube, which is converted to 368. The next object is irregularly shaped, the pebble. Since it is hard to find the volume of an irregularly shaped object like the pebble using a formula, we decide to use the Eureka can test, which makes use of the Eureka can, the measuring cylinder, and the tripod stand. This is as seen as the picture on the right. The test was repeated thrice to reduce any experimental errors. The test is done by first filling the Eureka can to the brim with water. Then the can is placed on top of the tripod stand, while taking note not to spill any water out. The pebble is then gently lowered into the water. The amount of water which is displaced will flow out the Eureka can's opening into the measuring cylinder, which is positioned below the tripod stand. The amount of water in the cylinder will be the pebble's volume.
This is a video of the Eureka can test.
To find the volume of the pebble, simply average out the 3 results from the previous table, and with the mass measured to be 55.4 grams, we can find the density of the pebble by dividing 55.4 grams by 21 cm cube. The density of the pebble is 2.64 grams per cm cube.
The third object is the glass rod. To find the volume of the glass rod, we need to find the volume of its top surface area and the length of the rod. To find the length of the glass rod, we use meter rule as the rest are not long enough to measure it. For the diameter, we use vernier caliper to get a more precise measurement. The results are repeated thrice and are shown in the table below. To find the area of the top surface of the rod, the formula is pi r square. To obtain r, divide the average diameter by 2. The top surface area will then be calculated to be 0.2892 cm square. By multiplying 0.2892 with the average length, the volume will be obtained. The mass of the glass rod is 23.4 grams as measured by the electronic balance. Therefore, by dividing 23.4 grams by 0.2892 cm square, the density of the rod is found to be 2.14 grams per cm cube. To ensure that the results are accurate, we need to take note of some precaution when conducting the experiment. For example, when measuring length using the specific instrument, read the measurement at eye level to prevent parallax error. This applies to the micrometer screw gauge, vernier caliper, and the meter rule. Next, check for zero error before using the specific instrument so that the result will not be affected. Reading should not be more precise than the final average reading. Make sure that the water surface in the Eureka can is not moving before finding volume of the object. Make sure there is no violent splashing of water when dropping object into water to find volume. Lastly, make sure to set the electronic balance to 0 gram before finding the weight of the object.